To model light pipes or light delivery structures within ASAP, you can either create the geometry within ASAP itself using native ASAP geometry, or you can create the geometry in a CAD program and import that into ASAP after an IGES or a GTX output. Let's take a look at a light pipe that I've already built using native ASAP geometry. And what we're going to look at in this case is, as I said, the light pipe, which we've made from a combination of a few ASAP geometrical objects. We're then going to send some light through that light pipe and get an idea of the efficiency and take a look at where the leakage occurs at the bend in the pipe. This is simply a pipe made of polymethyl methacrylate, which is a material within the ASAP unusual glass catalog. So let's just run the file from the top. The first thing we'll do is create the geometry, then we will position a source, and then we'll trace some rays through the system. These surfaces you see right here in cross-section are two detectors that we've positioned above and below the plane of the pipe to capture some of the rays that leak out at the bend. And you'll notice there are a few rays that have started to leak out. We also are modeling the Fresnel reflections that occur within the face, plus some rays that are going to TIR within the pipe are going to exit back out the front face as well, leading to a loss of efficiency in the light pipe. Now let's take a look at the results of the analysis. What we see here is the light pipe and the rays that either exited the output face. We see the rays that were lost through the input face, either due to total internal reflections or possibly Fresnel reflections off the exit face. We also see some of the rays that were lost due to leakage at the bend in the pipe. But what I'm going to do is reorient this system slightly, and what we can see are detectors that are in false color, giving us an idea of how much energy actually leaked at the bend as opposed to how much energy exited at the output face. And obviously looking at numbers might make a little bit more sense. So via the stats command within ASAP, what we can do is take a look at all of the information and look at the results of the stats command. And these are the two detectors. These are the ones calculating the leakage above and below the light pipe. And approximately 80% of the energy is exiting out from the back. About 10% of the energy, or 11%, is actually being lost at the front end due to Fresnel or TIRs that end up going backwards. And about 1% is going into the upper detector, and about 3 or 4% is going to the bottom detector. So by using this type of analysis, we can look at the efficiencies of our light pipe, and then we can go in and modify the shape to help improve that efficiency until we can get the desired response.